A linear equation is an equation whose graph is a straight line. And one of the forms of the equation would look like this: y equals mx plus b. M represents the slope of the line, and b represents the y-intercept. So we're going to be using the ideas in a linear equation for chapters 4 and 5. So I want to make sure that you guys really remember and understand how linear equations work. So when I have an equation in slope-intercept form, the number that multiplies the x, the coefficient of the x, is my slope. And we use the letter m to represent slope. And the number that is added onto the end, the constant in the equation, is the y-intercept. And we use the letter b to represent the y-intercept. All right, so let's talk about the y-intercept first. The y-intercept is where the line, the graph of the equation, intercepts or hits the y-axis. So if you remember, whenever we have a graph or a coordinate grid, you have two axes. You have your x-axis and your y-axis. The x-axis is the horizontal one, and the y-axis is the vertical one. So the y-intercept is where your line crosses that vertical axis, the y-axis. The y-intercept is the value when x equals 0. So if I were to plug 0 in for x into my equation, I would end up with whatever value b is, and that would be my y-intercept. If I'm thinking about it as a point on the line, it would be the point 0, comma, b. The x coordinate is 0, and the y coordinate is whatever that y-intercept is. So there's your introduction to the y-intercept. So now let's talk about the slope. Slope is the growth of our line. It is how steep the line is. How quickly does it grow? And the thing about slope with a straight line is that the slope will be the same no matter where on the line you are looking. So slope is the constant growth across the line. Now there are a couple different ways we represent slope. So some of you may have heard it referred to as rise over run, or rise divided by run. Rise is how much the line goes up or down, and run is how much the line goes from left to right. So rise over run is one way we represent our slope. Another way we represent our slope is by doing this. Now, I don't want you guys to get confused because we've been doing geometry now for a few weeks, and we've been using this the triangle in geometry to name a triangle. But this is not actually a triangle. This is the Greek letter delta. And the Greek letter delta looks like a triangle. In math and in science, we use the Greek letter delta to represent change or the difference in something. So when I'm looking at this, I would actually read this delta y over delta x. The change in y divided by the change in x, or the difference of the y values divided by the difference of the x values. And when I am talking about the difference of something, I am talking about subtracting those values, because difference means I am subtracting. Okay, so my slope can be represented by rise over run, delta y over delta x, change in y over change in x, difference in y values over the difference in x values. So let's take a look at how we can find the slope from a graph. So what we do a lot in my algebra classes and in geometry is we would draw something called a slope triangle. A slope triangle is a right triangle drawn on the graph of a line that helps us visually see the slope. You can draw your slope triangle anywhere along your line. You can make it as big or as small as you want it to be, but the most important thing is that you go from lattice point to lattice point. And here's what I mean by a lattice point. A lattice point is the points on a coordinate grid where the grid lines intersect. So if I'm looking at this graph, I'm going to look at my line and see where it crosses an intersection point of the grid. So here's one intersection point. So that's what I call a lattice point. And then I'm going to keep following my line down until I see it cross another lattice point, which would be down here. When you are drawing your slope triangles, you always want to make sure that you draw them from one lattice point to the next. And again, a lattice point is just where the grid lines intersect. So when you're drawing your slope triangle, pick one lattice point or where your graph crosses one lattice point, and then follow your graph down to where it crosses a second lattice point, and then that's where you're going to draw your slope triangle. So if I'm looking at this graph right here, I have a blue dot where my graph crosses the y-axis, and that would be my b value, my y-intercept. And then I can draw in my slope triangle going from one lattice point to the next. And you always want to make sure your slope triangle is a right triangle. And then that will tell me my delta y and my delta x. All right, now my line can either have a positive slope or it can have a negative slope. If it's a positive slope, my line is going to be going up and to the right, because I always want to describe it as if I'm looking at it going from left to right. So I'm always going to the right. If it's positive, it'll go up and to the right. And that would look like this. As I go from left to right, my line is going up. That means it has a positive slope. A negative slope means that as I look at it going from left to right, it is going down. But notice, both ways, I'm thinking about it as it goes to the right, from the left to the right. So a positive slope goes up and to the right, a negative slope goes down and to the right. So let's take a look at a couple different lines, and let's find the y-intercept, the delta y, the delta x, and the slope. So let's start with this blue line. Notice my blue line, as I go from left to right, it is going up. It is increasing, which means that it is a positive line. So we're going to start by finding the y-intercept, which is where my line crosses my y-axis. Now, when you have the graph and you're trying to find these things, it's really simple. You're just counting. There's no calculating involved. You're just counting. So I am just going to count. And I notice that this graph doesn't have a scale drawn on it at all, telling me how much each grid line is. So when there's no scale, you can just assume that each grid line goes up by 1. So that means I'm going to count from 0, and I'm going to do 1, 2, 3. So that means that my graph of my line crosses the y-axis at 3. So my b value would be 3. My y-intercept is 3. Now I have a slope triangle drawn in here, and you can see it goes from one lattice point up to the next lattice point. And that helps me find my delta x and my delta y. So let's start with the delta y. And again, I'm just going to count from this corner of my slope triangle. 1, 2. It went up 2, so my delta y is going to be 2. And then I'm going to count my delta x, and it went 1, 2, 3. So my delta x is 3. So since slope is always delta y over delta x, my slope is going to be 2 over 3. And I would prefer that you leave them in fraction form, because when your slope is written as a fraction, that tells you the rise and the run, and it makes your life a whole lot easier. So leave it in fraction form. Now let's take a look at this red line. This red line is negative because as I go from left to right, it is going down. This red line also happens to be crossing the y-axis in the negative region, but that doesn't have anything to do with why it's a negative slope. That just happens to be where it's crossing. So let's start with my y-intercept. I just circled it down here, and now I'm going to count from the origin. I'm going to count from 0, and it is 1, 2, so it's at a -2. So my b is -2. Now I have my slope triangle drawn. Here's one lattice point where my graph is crossing, and then I follow my line down until I reach my next lattice point, and then that's where I draw my slope triangle. Now this time for my slope triangle, when I'm finding my delta y, I am going down 1, 2, 3. So that means that my rise is a -3 because I went down instead of up. And then my run is 1, 2, 3, 4. So my run, my delta x would be 4. That means my slope would be -3 over 4. Now, there's another way I could write this, still keeping it as a fraction. Since it's a -3, I can put the negative out in front of the fraction, or I can put the negative in front of the numerator, and both of those are totally correct. It's just all how you prefer to write it. And again, when your slope is a fraction, leave it as a fraction.